All right, good morning, everyone. Here is today's lesson. Okay, last time we just talked about simplifying radical equations, and today we're actually going to talk about graphing them and talking about different parts of a graph when we are looking at rational expressions, okay? So, now that we're going to graph, we're going to see some restrictions and see how they're put into play, and we're going to see a bunch of different new things that you haven't learned yet, okay? So, before we go ahead and learn about the things you don't know, we're going to go over the things we learned from last lesson, okay? So, the first thing we are going to do is we are going to talk about this equation here, okay? This x plus 2 all over x squared minus x, or minus x minus 6, okay? So, the first step that we need to take is factor out the top and the bottom, okay? Now, in this case, my top is already factored in the simplest form, okay? So, that just stays the same. But on the other hand, my bottom needs to be factored, and I am going to use my a times c factoring, okay? So a times c, and in this case, my a is equal to 1, my b is equal to negative 1, and my c is equal to negative 6, okay? So in this case, my a times c is now negative 6. So what I need to do is list all of my factor pairs of negative 6, okay? And that is negative 1 and 6, 1 and negative 6, 2 and negative 3, and negative 2 and 3. When we're factoring negative numbers, it's important to remember that you need both sets of factor pairs, okay? Once you are at that point, you can go ahead and then choose which factor pair adds up to give you b. And in this case, b is negative 1, okay? And I know that 2 minus 3, or 2 plus negative 3, gives me a negative 1, okay? So when a is 1, if you remember, I can just write my parentheses like this. And then all I have to do is plug in my factor pairs. So I chose a plus 2 and a negative 3. Okay? So I did step 1 and I factored my equation. Okay? From there, I'm going to find my restrictions. Okay? And if you remember, finding your restrictions is using the zero product property. Okay? But I only use that with the denominator. So I'm going to set x plus 2 equal to 0, and I'm going to set x minus 3 equal to 0. Okay? I will, in the first equation, I will subtract 2 from both sides, and my answer will be x cannot equal negative 2, because remember, we need restrictions. We are not finding what x equals. We are finding what x cannot equal. Okay? And then I'm going to do the same thing with my second equation, only this time, I'm going to add 3 to both sides. So in this case, x cannot equal 3, positive 3, okay? So now we factor the equation and we identify the undefined points, okay? Now, my last step is to cancel out anything on the top that's the same as the bottom, right? We need to reduce it. So I noticed that x plus 2 and x plus 2 are on the top and on the bottom, so I could cancel both of those out. Okay, so that's what I learned about yesterday. Now, here are the 3 new things we are learning today. Okay, we are learning about vertical asymptotes, discontinuity, which just means that discontinuity is just, it's not continuous, right? So in this point, at some point, the graph will stop. Okay, it will no longer be continuous. And then the last thing we're going to learn about is horizontal asymptotes. Okay, so from here, we're just going to talk, the first thing we're going to do is we're going to talk about a vertical asymptote. And what a vertical asymptote is it is the leftover part of the denominator that is not canceled out. So what I want you to do is underline not canceled out, because that's important. Okay? How we draw a vertical asymptote on a graph is a dashed vertical line, okay? Which means that it is just goes like this. Vertical meaning up and down, and it's going to be somewhere on our graph, okay? In order to find our vertical asymptote, we need to set it equal to 0 and solve for x. So this is just the zero product property again, okay? And then lastly, when we find our vertical asymptote, it is always set as x equals. So we're always writing it in the form as x equals, okay? So before we go on to anything else, we are going to find the vertical asymptote of our top equation up here, okay? So what the vertical asymptote is, it is the part of the denominator that is not canceled out, okay? So when I'm looking at my example up top, I did not cancel out x minus 3, okay? So that's what I didn't cancel out, so that's what I'm using. And in order to solve for that, I need to set that equal to 0 and solve, okay? Now, we all know that I would add 3 to both sides, okay? And what I would be left with is x equals 3, and that is my vertical asymptote. Make sure we are no longer saying it is not equal to. That's only our restrictions. When we're writing our vertical asymptote, it's saying x equals 3, okay? So remember, that's whatever is not canceled out. So that's one thing we're going to learn about, okay? On the other hand, we're going to learn about a discontinuity, or the term we use about this in math is the word hole, okay? So in a graph, if we see a hole, that means the graph is not continuous. That means it's going to jump over the point, okay? So that's important. But what's most important, in order to find what the hole is we are looking for the part of the denominator that is canceled out. So the vertical asymptote, it is what's not canceled, and the hole is what is canceled, okay? How we would draw this on a graph is just a small open circle, so it would look like this in the graph, okay? Same thing, in order to find our hole, we are using the zero product property, okay? And how we write a hole is in this form. Now, every time we write a hole, we're only going to have an x point. Okay, there's only going to be a number in for x. Other than that, you see those 2 dashed lines, that's what we are going to use for our y. Because when we're looking for a hole, we're really only worrying about the x. In most cases, our y will be some crazy point that you won't be able to figure out. It'll be like 1.333, and you'll never know, right? So all I really am worrying about is what my x value is, okay? So looking at my example, I am looking at the part of the denominator that is canceled out. And what part was canceled out was x plus 2, okay? And in order to solve that, I need to set x plus 2 equal to 0 to solve, okay? So in this case, I would subtract 2 from both sides, and I would be left with x equals negative 2. But remember, we don't want it in that form. We want it as a point. So in this case, my x value would be negative 2, and I would just leave a dash as my y value. I am not worried about the y value, okay? I'm only worried about the x value, okay? So that's how we find a vertical asymptote and a hole. Now, those two definitions and charts right there are going to be super important for you to refer back to, okay? You're going to need it because it's hard to remember sometimes which is which, okay? So both the hole and the vertical asymptote are working with x. But now we also need to work with y, okay? And what we work with y is called a horizontal asymptote, okay? Now this is a little bit different. Here, we are just looking at our exponents. In order to find what our vertical asymptote is, this is all about exponents, okay? So there are 3 different vertical asymptotes that we can have, okay? And I'm going to list 3 examples for you. So the first type of vertical asymptote we can have is when the top exponent is higher than the bottom exponent. So an example of this would look like x squared minus x minus 6 all over x plus 2, where the top exponent is bigger than the bottom, okay? And in this case, when our top exponent is bigger than our bottom exponent, we do not have a horizontal asymptote. So what you would write is just none. You would say that there is no horizontal asymptote, okay? So that's one type of horizontal asymptote. Another type of horizontal asymptote is when the top exponent is smaller than the bottom exponent. And an example of this would be something like 6x plus 18 all over x squared plus x minus 6, okay? Where my bottom exponent is bigger than my top, okay? And when your bottom exponent is bigger, your horizontal asymptote is always y equals 0, okay? All right. in the last case, when the last type of horizontal asymptote we can have is when the exponents are the same on the top and they're equal on the bottom. So an example of this would look something like x plus 2 all over x minus 4, where our exponents are the same. Okay, in that case, our exponent would both be 1. Now, when our exponents are the same, what we do is we take the leading coefficient of the top and the leading coefficient of the bottom and just keep it as a fraction, or if we can reduce, we reduce it to a whole number. Okay? So, for example, in this case, our asymptote would be 1 over 1, which would just leave me with y equals 1. So that would be my horizontal asymptote. Okay? Now, let's look at our original equation. So we're looking back here. Okay? My horizontal asymptote, in this case, my bottom exponent is bigger than my top. So my horizontal asymptote would be y equals 0. Okay? So this chart is super, super important. Okay? You're going to need to keep it safe. You're going to need this because some things can get very confusing. So you're going to have to refer back. Okay? So when you're done, I want you to go ahead and flip over to the next page. All right, so now we're going to do some examples. Okay? So the first thing I want you to realize is that when we have a dotted line, so looking at this line, that is a horizontal line. So that becomes our horizontal asymptote. Okay, so I just want you to realize what they look like. Okay, so a horizontal dashed line is your horizontal asymptote, while a vertical dashed line is a vertical asymptote. Okay, I abbreviated horizontal and vertical, but you guys should understand that. Okay? All right, so we are going to do 2 together, and then you're going to do 2 on your own. Okay? So, in case number 1, let's do number 1 together. We have to factor here, right? I need to get this in its simplest form before I could find any asymptotes. So, in this case, I need to factor my top. I'm going to zoom in a little bit so I have more room to write. Okay? So, for my numerator, my a is 1, my b is -1, and my c is -2. Okay? So when I multiply my a times c, I am left with a -2. And all my factors of -2 are 1, and -2, and -1, and 2. Okay? Now remember, I need to circle the pair that adds up to give me a -1. And in this case, it's 1 and -2. So, when a is 1, I can just write parentheses with an x in front and then fill in. So I did a +1 and a -2. Okay? Then I'm going to do the same thing with the bottom. So I have a equals 1, b equals -1, and c equals -6. Okay? Where in this case, a times c is -6. And I can list all of my factors. So, -1 and 6, 1 and -6, 2 and -3, and -2 and 3. Once again, I need my factor pairs to add up to give me a -1. And in this case, this factor pair would be the one I choose, where I can, once again, a is equal to 1, so I could just put an x in front, okay? And then fill in, so x plus 2 and x minus 3, okay? So that's what I'm going to be looking at. I'm going to write it a little bit bigger so when I zoom out, we could see x plus 1, x minus 2, all over x plus 2, x minus 3, okay? So now that we've done this, we can go ahead and identify our holes, our vertical asymptote, and our horizontal asymptote, okay? So the first thing that we need to do is find what our hole is. And if you flip back over to your front page, a hole, so before we do that, actually, I want you to look at this original equation and notice that there is nothing that can be canceled out here, okay? So that's important. So nothing can be reduced. So when identifying our hole, we have to look for our crossed out term in our denominator. But in this case, nothing's crossed out. So I do not have a hole. So you're just going to write none. We don't have a hole in this example, okay? All right, now looking at our vertical asymptote, we are looking for the parts that are not canceled out in our denominator, okay? That are not canceled out. So in this case, I have x plus 2 that's not canceled out, and x minus 3 that's not canceled out. And what I want to do with those is just set them equal to 0 and solve, okay? So in this case, I would have x equals 2, and in this case, I would have x equals 3. That's supposed to be a negative 2, okay? And those would be my vertical asymptote, x equals negative 2 and x equals 3, okay? So then the last thing I need to look for is my horizontal asymptote. And if you remember, horizontal asymptotes are looking at our exponents. So I'm going to go back and look at my original equation, okay? And I noticed that my exponents are the same. So what I'm going to do is I'm just going to put the top leading coefficient over the bottom. And in this case, my top leading coefficient is 1, and my bottom leading coefficient is 1. Which is just equal to 1. So my answer here is y is equal to 1. Okay? All right, let's do one more example, and then you're going to try some on your own. Okay? So, look in here now. Okay? The first thing I need to do, I'm going to zoom in. I need to factor my numerator, okay? Because I need to get this simplified up top. So the first thing I'm going to do is I'm going to list my A, B, and C, okay? And once I've listed my A, B, and C, I can then go ahead and factor negative 3, because that's A times C. And my factors of negative 3 are 1 and negative 3 and negative 1 and positive 3, okay? Then I could choose which factor pair gives me a positive 2. And I know that 3 minus 1, or negative 1 plus 3, gives me a positive 2. Okay, so I've chosen my factor pairs. Now, because A is 1, I can just write 2 parentheses with an X and fill my factor pairs in. Okay, now on the numerator, I don't need to, on the denominator, I don't need to touch anything. So I can just leave it as X minus 1. Okay, all right. From there, you should immediately notice that you can cross out X minus 1 on the top and X minus 1 on the bottom. Okay, so that's as reduced as we can go. Then, from there, we're going to answer the questions. We are going to identify our whole, our vertical asymptote, and our horizontal asymptote. Okay, so in this case, remember, when we are talking about a whole, we are talking about the part that's canceled out. In this case, only in the denominator. That's important, okay? In this case, our x minus 1 was canceled out. So we are going to say x minus 1 equals 0 in order to find my whole, okay? And I'm going to use the zero product property. So if I have x minus 1 equals 0, I'm going to solve using the zero product property, and I get x equals a positive 1. But remember, I want it in the form of x, comma, dash. And in this case, my x is 1. So I'm going to replace x with 1 and leave my dash. Okay? Then my vertical asymptote is what is not canceled out in the denominator. In this case, there is nothing else left in the denominator. So I do not have a vertical asymptote. You can write none or just leave a dash. Okay? And then lastly, I need to find my horizontal asymptote. Remember, our horizontal asymptote is when we are looking at our exponents, okay? So, in the case that the exponent is bigger on the top, our horizontal asymptote is none. We don't have one. So when the exponent on top is bigger than the exponent on the bottom, we do not have one, okay? So that's how we complete things like that, okay? I am going to have you complete the bottom two on your own, and then I will post pictures later on of the answers so you have them, okay? All right, turn the page. And once again, I'm going to have you do the same thing up here as well. So 1, 2, and 3, you're going to do on your own, all right? And then I will post pictures for you to see them after. Okay? But we are going to do one of these we'll probably do all these practice problems together, okay? So here is a little bit of different way to identify our holes, our vertical asymptotes, and our horizontal asymptotes, okay? So the first thing we need to do is identify a hole. And if you remember, a hole is symbolized as a little circle in the graph, okay? And in this case, I see a little hole right here, okay? So I know that I have a hole. And remember, when we write a hole, we write it as x, comma, dash, okay? So in this case, we only want our x value, okay? And when we're looking for our x value, we're looking where it ends up on this line, okay? On this line. Okay. So remember, our x always goes left to right, while our y goes up and down. So in this case, my hole is at -1. So my point would be -1, comma, dash. Okay? Now, this is a little bit easier. A horizontal asymptote is a little bit easier to see here. Now, in a horizontal asymptote, we're just looking for the dashed vertical line. Sorry, we're looking for our vertical asymptote. So we are just looking for the line, the dashed line that goes up and down. Okay? And we're looking at the point that it lands on our x-axis. Okay, so in this case, x would equal 4 because the line goes up and down on the 4. Okay, now my horizontal asymptote would be a dashed line that goes left to right. And here it's a little bit difficult because it's on these it's on the 0, right? So in this case, y would equal 0. All right. So now looking at number 2, we're going to do the same thing. Remember, a hole is defined by a little hole in the graph. And here we see that. Okay. So at this point, we need to find, remember, it's going to say x, comma, dash. Okay. So in this case, is our hole moved off of did it go left or right? No, it stayed as 0. So my hole is 0, comma, dash. Because it didn't go anywhere on the x-axis. It only moved down. It didn't move left or right. All right. So my next is then to find my vertical asymptote. So remember, I'm looking for my vertical dashed line. Okay. And at this point, x equals 3 because it's on the 3. It goes through the 3 on my x-axis. And then I'm going to look for my horizontal asymptote, which is the horizontal line, and where it ends on my y-axis. So in this case, my horizontal is y equals 2. Okay? And then the last one, I'm looking for my hole. There's no hole here, right? There's no little circle on our graph. So the hole is just none. We don't have a hole. Okay? Now in this case, we have 2 vertical asymptotes. Right? We have a dashed line here and a dashed line here, which means I have 2 x values, okay? One is on -2, and one is on 1. All right? And then the next one we are looking for is my horizontal asymptote. And once again, the horizontal asymptote lays on the 0, okay? So my horizontal is y equals 0. All right? So just remember that you are going to go ahead and do numbers 1, 2, and 3 on this page and 3 and 4 on the page before this. Okay, I will post pictures later on so you have the answers. Okay, if you have any questions, let me know.